Good afternoon and welcome. Thank you for joining us for a webinar on the economics of soil health systems on Ohio farms. My name is Byron Rath and I serve as the Soil Health Institute Sustainability Specialist. Soil Health Institute is a 501c3 nonprofit, and our mission is to enhance and protect the vitality and productivity of soil through scientific research and advancement. Today's webinar is the 8th in a series of 9 state-based webinars on the economics of soil health systems. And this research aims to address the most frequent question that we receive from farmers, landowners, and their advisors. And that is, what are the economics of adopting soil health practices and systems? So to answer this question and address this knowledge gap, we interviewed 100 farmers across 9 states who have been successful in adopting these systems. And today we'll be sharing results from 11 farms that we assessed in Ohio. In June, we'll be releasing an aggregated fact sheet of all 100 farms that were assessed. This project was not designed to be a random sample of all farmers and their economics, but instead to intentionally interview farmers who've been successfully implementing soil health systems for 5 or more years so that we can understand the economics of those systems as compared to their conventional counterparts. So tomorrow, you'll be receiving a recording of this webinar and the fact sheet from the 11 farms assessed in Ohio. And that information can also be found on the Soil Health Institute's website at soilhealthinstitute.org/economics. During today's presentation, please enter your questions in the Q&A box at the bottom of your screen and upvote any questions that you'd like to have answered. And our speakers will address those questions in our last 15 minutes. So a big thank you to Cargill for their support of this work, and a sincere thanks to the 11 farmers in Ohio and the 89 farmers in the other 8 states who agreed to be interviewed as part of this research. You know, without Cargill's support and those farmers' participation, this research and these results would not be possible. And so with that, I would like to introduce Mr. Ryan Ciroli, Global Row Crop Sustainability Director at Cargill, who will offer opening remarks and will introduce Dr. Archie Flanders.
Thanks, Byron, and thank you all for taking the time to join us today. On behalf of Cargill, I'd also like to offer sincere thanks to all of the growers who so willingly offered to share their insights and their experiences to bring this study to life. Without their openness, this work would not be possible. I'd also like to thank the Soil Health Institute for their leadership and their incredible knowledge to help us better understand the economic benefits of adopting soil health management systems. I believe that this work is a critical question and that we need to better understand as we look to scale soil health management systems. I'd like to ask you as attendees to submit your questions for the panel using the Q&A feature, and that as registrants, you'll receive the fact sheet after the webinar concludes and a link to the webinar recording on Friday. With that, I'd like to introduce Dr. Archie Flanders. Dr. Flanders is an agricultural economist at the Soil Health Institute, where he assesses the economics of soil health promoting practices and land management systems. He works with producers and agricultural researchers to develop decision support tools that farmers and ranchers can use to make informed decisions about production practices on a field-by-field basis. Previously, Dr. Flanders served as a faculty member at both the University of Georgia and the University of Arkansas with research and extension responsibilities in production economics, farm management, and economic development. Dr. Flanders is a member of the Agricultural and Applied Economics Association, as well as the Southern Agriculture Economics Association. He received his BSA in General Agriculture and his MS and PhD in Agricultural Economics from the University of Georgia. So with that, I'd like to hand it over to Dr. Flanders.
Thank you, Ryan. And also, we'd like to thank Cargill for recognizing the importance of this topic and providing us this opportunity. And then I'd like to restate our appreciation to all the farmers in Ohio and all the other states that participated in these interviews with John and I so we could obtain this information to do this economic analysis. There's quite a bit of research that associates improved soil health with farm level benefits such as drought resilience, improved nutrient uptake by crops, disease suppression, and reduce erosion, which also reduces nutrient loss. Also, Research indicates that many soil health practices also have environmental benefits, such as storing soil carbon, reducing greenhouse emissions, and also improving water quality. However, an often overlooked and unanswered question is the economics of these soil health activities. Adopting and investing in soil health management systems is a business decision. And so that was our goal and objective, is to provide farmers with the economic information they need when deciding whether or not to adopt soil health management systems. Our approach was to seek out and interview farmers in Ohio. It was 11 farmers who had adopted soil health management systems for a minimum of 5 years. And then based on their production information, we wanted to calculate partial budgets that would compare the benefits and cost before and after adoption of a soil health management system. We have more details available on our methodology posted on our website. In partial budget analysis, the word is partial because we're only interested in part of the budget, and that is only the differences between management systems are included in partial budget analysis. And in calculating the revenue portion of the partial budget analysis, we recognize that market prices fluctuate. And we calculated any potential changes in revenue by using a standardized set of long-term average prices. We'll have more information in our fact sheet about how we came up with the long-term average prices. For example, when we began this project, prices were at historical lows. At the time we were completing the project, the prices were at relatively historical highs. We wouldn't want to use either one of those, so we took long-term averages. And then finally, USDA payments are not included in the analysis. Some of the farmers did begin their soil health management practices with USDA assistance. Often these payments are limited in time duration. It may not be available on all acreage. So we didn't want to conflict our final results by including payments that may not be able to be applied every year over all the acreage. These are some characteristics of the farms, 11 farms in Ohio. You see each one of the white dots is one of the 11 farms, so we got good geographical distribution within the state of Ohio. We have a good range of temperature and participation in the state, growing degree days for corn, average right at 3,000. And then finally, look at the acreage. They're about evenly distributed between soybean and corn acreage. But the important thing to note that these are full-scale size farms. These aren't just small research type plot farms. These are full-scale operational farms. So our results will be able to be applied also to large-scale farms. And looking at our sample, 87% of the acreage in our 11 farm sample in Ohio had no-till practices. This compares to, in the state of Ohio at large, 47% of acreage is in no-till production. In the U.S., it's 37%. The balance of the acreage in our sample of Ohio farms was in some form of reduced tillage. And in the Ohio as a whole, as a state, 34% is reduced tillage and 35% in the U.S. is under reduced tillage. We had no intensively tilled acreage in our sample. And then with cover crops, we see that 54% of the acreage in our sample was devoted to planting of cover crops. This far exceeds the average in Ohio, which is 8% of the acreage, and then 5% of the acreage in the U.S. has cover crops. Now, we mentioned that our goal was to do partial budget analysis, and this is the results. This table is quite busy with numbers and listings, but we'll go through it and point out the highlights. These are the partial budget results for corn and soybean in Ohio that we did with partial budget analysis with data collected from our interviews. Let's look at the first expense category. Well, before we start going through the expenses, let's give some description of what it is. We have cost and benefits are listed with green numbers, and costs are listed with red numbers. When you adopt the soil health management system and you change your production practices, there are two different types of expense occurrences. When you take on a new production practice, you have additional expenses, but likewise, you also have reduced expenses. So in our red column, we have additional expenses that are incurred on average when you adopt the soil health management system for corn. And in the column right next to it, we have reduced expenses. You get rid of some activities, and so these become reduced expenses. So now let's look at the top line, the seed category. For additional expenses, this is $17.11, which is an average across all 11 farms. Now, additional seed expenses primarily are going to be cover crops, but also it could be some seed treatments that are involved with adopting a soil health management system. Reduced expenses could also be seed treatments, but sometimes when you adopt a soil health management system, it is what enables the farm to potentially plant non-GMO seeds, which have lower seed costs. So this could also be a reduced expense. So let's look at the additional expenses for seed for corn and soybean. The average seed expense for corn additional expense is $17.11. However, this is over all 11 farms. If we go back and look at it in a little more detail, 8 of the farms planted cover crops before producing corn. The average seed cost for those 8 farms was $23.53 for the cover crop seed. Likewise, we can look over at soybeans, and 5 of the farms planted cover crops before producing soybeans. So for these 5 farms, the average cover crop seed cost was $14.40. So it's usually in Ohio, it was about $10 more for the cover crop seed for when you're planting before corn than it is when you're planting before soybean. And this is because the different seed mixes before corn, you're usually trying to get some legumes in the cover crop seed mix so you can have some nitrogen for corn production. So going on down to the next line, we see fertilizer and amendments. Adopting the soil health management system on average allowed the farms to reduce fertilizers by $24.46 for corn, $10.28 for soybeans. Going back again to the cover crop example, this is because of the nitrogen requirements to produce corn. There's a greater initial level of fertilizer required for corn, so also there's likewise more potential for reductions. Going on down to the next rows of fuel and electricity, labor, and services. Fuel would be diesel fuel for tractor operations. Labor would be operating labor for the equipment. And sometimes when you're either adopting a soil health management system, you may have hired custom labor services, such as planting the cover crop. So all these categories are included in labor and services. But notice we do have some additional labor and services for both corn and soybean, but the reduction is greater than the additions for both crops. And then equipment ownership. This is our methodology that's described in more detail on our website. The equipment that is used, we come up with a per acre cost. And so we see that when you adopt a soil health management system for both corn and soybean, the reduction in your equipment expenses is greater than any additions that also might be incurred. And so then down at the revenue section, some of the farms reported increased yield due to the soil health management system. And so in this case, this is going to also have increased revenue. For corn, the revenue increase averaged $33.54, and there were no farmers reporting yield decreases due to the soil health management system. For soybean, the average yield increase, including the ones that reported some increase and those who didn't report an increase, was 2.18 bushels, and this comes out with a revenue calculation of $21.80. In additional revenue, like for corn, there were no reports of decreased yields. So if we sum up the benefits and the cost, for corn, the total benefits are $118.46, and for the additional expenses or costs are $53.37. Therefore, the change in net farm income is $65.09 for corn. Following the same procedure for soybean, the increase in net farm income is $37.48. Going back and looking at expenses, let's consider a situation if we didn't have a yield increase. The only thing that was involved would be the expense decreases. In that case, we would still have an increase in net farm income, not including anything from revenue, and the reduced expenses for corn are $35 greater than the additional expenses. So net farm income increase is $35 just for the part that's attributable to the expense decreases. And for soybean also, just counting the production expense decreases, net farm income would increase by $16 an acre. Now let's look at the individual farms in Ohio with the net farm income increases. We had a range from minus 37 all the way up to 169. This means that from adopting a soil health management system, 3 of the farms actually experienced a decrease in net farm income from where they were with conventional. For soybeans, only one farm had a net farm income decrease due to adopting the soil health management system. But let's keep these decreases in perspective. We do have quite a range from some decreases all the way to some large increases. But oftentimes let's keep in mind that these decreases are changes. These farms continue to be profitable with the soil health management system. Otherwise, they wouldn't even have been in the sample, because our sample was those who have been practicing for 5 years or more, and it's profitable, or otherwise they wouldn't continue with it. But sometimes it may be that a farm will adopt a soil health management system for one crop and have a decrease in net farm income, but the increase for the other crop may be greater than that decrease. Also, some farms may take a net farm income decrease for a farm, but they didn't. It was better than the alternative. With the soil health management system, they've been able to reduce total debt. They don't have to hire labor, but maybe not was available So in some cases, a reduction in net farm income is better than the alternative, which would be for the farm to go out of business. Now, in addition to the net farm income increases that were determined by the partial budget analysis, we also asked the farmer some direct questions of the benefits of a soil health management system. And 64% reported increased yield from a soil health management system. 82% reported fertilizer decreases. And then on down, increased crop resilience was another benefit. Field access is a benefit, and especially during the springtime when it's rainy weather and the fields otherwise wouldn't be accessible. The improved soil structure allows the farmers to get into the field. Improved rental arrangements were also mentioned. Improved water quality. Farms with protection for license to operate. Many of the farmers thought that this was their soil health management systems were heading off potential regulations. And 73% reported increased soil organic matter. Now, some highlights of our analysis. The average farm size was 1,095 acres. No-till was used on 87% of the acres. Cover crops were planted on 54% of the acres. The soil health management systems reduced average production costs by $35.11 for corn, $16.38 for soybean. And the soil health management system increased net farm income by an average of $65.09 for corn and $37.48 per acre for soybean. Based on current adoption rates of 47% of no-till and 8% with cover crops in Ohio, Ohio farmers could increase their net farm income with adoption of soil health management systems. As Byron mentioned earlier, these fact sheets and recordings will be available on our website tomorrow. And once again, I'd like to express our appreciation to Cargill for making this work possible, and also give our appreciation to the farmers for willing to participate.
All right, thank you very much, Dr. Flanders. So we have about 5 to 7 minutes or so for questions. If you have a question for Dr. Flanders, Dr. Honeycutt, Dr. Shanahan, or Mr. Ciroli, please enter those in the Q&A. Sushant asks in the chat, Archie and Wayne, when do farmers start seeing profits after soil health management practices are put in place for the first time on their farms? And then a second part to that question, can you comment on which soil properties start showing benefits sooner rather than later? Specifically, soil infiltration may take years. So Dr. Honeycutt.
Yeah, I guess I'll take the first stab at that and then see if Archie would like to offer any qualifying comments too. I think that in my understanding is that some of the gap before things become more profitable is kind of a knowledge and experience gap. It's not all a biological gap is my point. And I do feel like that there's more information that we need to get here, that we need to work with more farmers during that transition period to understand the transition they're going through, and then hopefully perhaps increase and expedite their ability to be economical. But my understanding is that in general, it does take 3, sometimes 5 years. I think it depends on things like your climate you're in, what production system you're in, what your management practices are. Just specifically, for example, are you growing corn for silage or for grain? If you're growing it, for silage, then now you're removing most of that plant biomass off the ground, and you're not returning as much carbon to the soil. But if you're harvesting just for grain, now you have an opportunity for really significantly increasing the carbon input into that soil. And so that's kind of a direct example of how which management practice you select really affects your carbon input into that soil, and therefore your ability to improve the health of that soil faster in one situation compared to the other, depending on the management practices. And then, of course, you can overlay different aspects of that, like which climate you're in. And, decomposition it occurs at one rate, depending on, how cool or warm it is, and also how wet or dry it is. And so all these factors influence how fast you can really start to accrue those benefits of soil health that will then show up in those economic assessments. Now, in terms of your second part of your question about, kind of which measurable attributes of the soil that start to show up first, often we see that it's more of those what's referred to as the labile fractions of carbon, meaning that it's not so much the total carbon, but that in the particular component of that, that's much more readily available to the microorganisms to feed on. And so those types of measurements can be really helpful in helping you see that you got to start on it. But kind of the really important one is that total organic carbon, sometimes referred to as the total organic matter. They're related, they're different, but they're related. And that is something that generally takes a few years to have a measurable change. Doesn't mean you're not having a change, but in order to have that measurable change where you can separate your measurement away from the background variability that's there. That generally takes also 3 to 5 years to have that measurable change in organic carbon. But some of those other fractions of carbon that address what the kind of indicator of microbial activity and stuff like that you can generally start to pick up sooner than that. Hope that helps. Sorry for the long-winded answer, but it's a very good question.
All right. Dr. Flanders, did you have anything to add, or should we have another question here from Franz Brandl?
No, that covered it very well. I don't have anything to add.
All right, excellent. All right, well, the only other question that we have here is from Franz Brandl. He asks, Dr. Flanders, what's the impact of the cost of pesticides?
Oftentimes there are some decreases in pesticides. I know we had it, and I don't remember what the numbers were, but we do, talking to farmers, sometimes adopting a soil health management system often provides weed suppression. And so farmers are able to cut back on some of the herbicides because of the benefits of the cover crops. Usually when you have a pesticide decrease, it's associated with planting of cover crops. Also, sometimes cover crops provide a host for beneficial insects. And we did have some reports of farmers telling us they've been able to, in addition, decrease herbicides to decrease insecticides because they're attracting more beneficial insects. So it becomes, especially with cover crops, it becomes more of a regenerative system. Get many things working together.
All right, thank you, Dr. Flanders. And thank you all for joining us this afternoon for the economics of soil health systems on Ohio farms. Tomorrow, you will be receiving a recording of this webinar along with a link to the fact sheet. So please be on the lookout for that. Also, if you have a minute, please do take 2 minutes to answer our survey at the end of this webinar to help us improve future webinars. We greatly appreciate your feedback as to how we can improve. So thank you again for attending, and I hope everybody has a wonderful afternoon.